My name is Ron Matchoro, and I'm a product manager on the SQL security product team. I'm here with Mirek, Roit, and Jakov, who are my colleagues in SQL security product team. In this session, we would like to share and demo the latest SQL improvements in security and networking. Please don't forget to share your feedback in the end, so we will be able to see our session evaluation. Okay, once a year, Verizon publish a report that analyzed thousands of security and data breaches that were reported by organization during the previous year. As you all know, no organization is immune to data breaches. However, there are some interesting facts that I want to share from you with this report. First of all, around 70% of the reported data breaches involve on-prem assets. In the case of SQL, we're talking about on-prem SQL servers. Second, most of the data breaches involve sensitive data with financial value. Again, in the case of SQL, we're talking about SQL server that contains sensitive information such as credit card numbers, personal information, or intellectual properties. And the latest fact, which is interesting, is that 30% of the attack involve internal actor within the organization, which means we're talking about admin that have access to the SQL server. You don't need Verizon report to tell you how important it is to protect your SQL estate. But the good news is SQL offers you a powerful security capabilities that help you secure your SQL estate and the sensitive data inside. So let's see what the newest thing that we have to offer you. So I will start by sharing Azure Defender for SQL. Again, our new initiative to protect SQL anywhere with advanced capabilities. Then I will head it off to Mirek. We will share with you customer lockdown for Microsoft Azure. Then my colleague Roit will share with you the latest improvement in the network security for Azure SQL Pass. And last but not least, Jakov will share with you the latest news in the data protection. So let's start with the Azure Defender for SQL on anywhere. Some of you may know already familiar with the SQL Advanced Data Security capabilities we are offering for a while for SQL Pass on Azure. Azure Defender for SQL is our new brand for these capabilities, which include two main functionalities. We're talking about advanced threat protection that allow you detecting suspicious activities to breach your SQL server, and vulnerability assessment that allow you to discover and fix security misconfiguration. My big news for you today is that Azure Defender for SQL can allow you now to protect your SQL server outside Azure. And when I said outside Azure, I mean SQL on-prem, SQL on AWS or Google Cloud, etc., which is, again, vast majority of our SQL servers available over there. So what's included in the Azure Defender for SQL Server outside Azure? First, it's super simple to enable. Just like you are able to enable advanced threat protection and vulnerability assessment for your SQL Server on Azure, you will be able to do it with an on-prem SQL Server. And the good news, it requires no modification to your application code. Second, it supports for the first time old version of SQL. We know that many of you have SQL Server 2012, 2014, 18. Now you will be able to use the Azure Defender functionality and protect your SQL Server. Third, and again, I will demo it in a second, it includes all the good and advanced stuff for vulnerability assessment and advanced threat detection that help you to detect and prevent very popular threats on SQL Server that we see in the world. And last, all the security alerts that Azure Defender for SQL generates are integrated in Azure Sentinel. Now let's see Azure Defender for SQL in action, address one of the most major attacks we see in the world against SQL Server on-prem. Okay, so now I'm enter Azure Security Center. So the first step is first enable Azure Defender for SQL. So within one click, you will enable Azure Defender. And with you that, you will be able to protect your entire SQL estate, both inside and outside Azure. Once you enable that, you will be able to visit in Azure Defender dashboard which will provide you an holistic view, a centralized view of your threat protection capabilities across your multi-cloud and hybrid environment. It includes the latest status of your data and compute workload. Again, in many cases, you want to protect the SQL Server only. But again, there might be cases when the VM is accessing the SQL. It might be there are cases that the SQL backup is stored in the storage. So you do want to make sure that all the SQL Server and all the related workload are being protected. Now let's drill into a specific SQL on-prem server. So now I navigate to Azure Arc enabled SQL Server. As you can see, this is a SQL on-prem server. It's SQL 2006, located outside Azure, and it's connected through Azure Arc. What you see clearly is, first of all, you see it's provide you the similar experience that you have today for a SQL in Azure, but this is an on-prem SQL. The first thing that you can see, that Azure Defender provide you a set of recommendations that helps you to improve your security posture on the SQL layer and on the Windows machine that the SQL running on. So I will start by drilling down to the SQL vulnerability assessment. Azure Defender for SQL runs a set of security checks ongoing. And these security checks are basically providing you the ability to identify security misconfiguration, its extensive permission, and security sensitive data which is in risk. As you can see, there are two typical findings that are found here, which indicate that this SQL Server is vulnerable for a cyber attack. You see that the SA is enabled, and you see that XP PowerShell is enabled. When I click on the SA finding, it's provide me more information. It's provide me the description, remediation, even a query that allow me to fix the vulnerability. In addition, it provide me security benchmarks that are related to this security finding. Back to the SQL Server. So we mentioned the vulnerability assessment and all the security posture capabilities that Azure Defender offers you. In addition, Azure Defender offers you advanced threat protection, again, on the SQL layer and on the Windows layer. So as you can see, Azure Defender for SQL has detected potential SQL brute force attack on your server. I will click on the alert, and now I will see more information. You can see that the attacked resource is a SQL Server that is on-prem. I can also see that the SQL Server was tagged for production environment. So it seems to be that it's a very important SQL Server. On the right, I can see more details on the suspicious activity that was detected. I can see that the attacker has attempted to run 100 times failed login while exploiting the SA username. Now let's see what Azure Defender for SQL recommends me to do. As you can see, Azure Defender for SQL recommends me to basically block the IP address that is associated with this attack and disable the SA login. Lastly, Azure Defender alerts are being integrated with Azure Sentinel. Azure Sentinel is Microsoft native cloud SIEM. So that will allow the SecOps team using Azure Sentinel to view all the security incident on the SQL Server across your Azure and outside Azure. So as you can see, automatically the brute force attack appear in the dashboard for the SecOps. Another thing that the SecOps can do, it can investigate the alerts. Sentinel has a lot of very powerful investigation tool. So I will click on investigate, and now I'm in Sentinel investigation graph. As you can see, this is the SQL, this is machine that hosts the SQL Server. I can see the brute force alert, but I also can see that there was additional 2 security incident on this machine. Going through the timeline, I can understand that the attack started with SQL. It was succeeded. So basically the brute force attack has managed to gain access to the SQL Server. Then the attacker ran XP PowerShell, which means that the attacker was able to access the Windows layer of these SQL servers. And then he dropped and execute a malicious code. One of the popular attacks on SQL Server on-prem that we see in the wild is this pattern. Again, starting with the brute force, then going to the XP PowerShell, getting access to the Windows machine, and then dropping a malicious code such as crypto miner or ransomware. So you just saw the power of Azure Defender and Azure Sentinel, which can help you to prevent and respond threats on your SQL Server, both inside and outside Azure. I will now head it to Mirek, which will share with you update on customer lockdown for Microsoft Azure. Thank you.
Hello, my name is Mirek Steino, and I will present the customer logbox for Microsoft feature for Microsoft Azure. The Microsoft logbox is a feature that was developed in collaboration with different components, different services. Obviously, the main part was the logbox itself, but with a couple of others. There was a JIT, and then underlying services, where SQL is definitely one of them. So what this allows, it provides the interface for customers through the logbox who can now approve or reject the access to the data. In the rare situations, our teams, the Microsoft engineering team, needs to access customer data. As I said, this is very rare, but it happens to debug, to understand, to analyze, and to fix the problem. And this is the time where customer is strongly involved, knowing exactly what database do we or what resource do we want to access. And obviously customer can agree or disagree with this. And in addition, what customer gets is it gets the auditing records on different levels, in this case from the logbox itself and from SQL. This feature is in public preview, and it requires the Azure support plan with a minimal level of developer. So customer has to sign up for this plan. It is supported now for Azure SQL, for SQL DB, Synapse Analytics, and MI, and customer can sign up for this as part of the preview. So let me go through the customer logbox workflow. And typically it starts with the customer opening a support ticket. If there's an issue, things that customer cannot solve on himself, the support ticket, and this is a regular process, is then handed over to the support engineer who tries to solve the problem. In case the support team cannot solve it, the support team engage the product group. Once the product group is involved and the product group comes to the point that they really need to access to the customer data, this is the time where customer is involved to approve and deny such request, and this is done through the lockbox. So customer there specifies exactly what resource is needed, and gives finally a permission to access the data. With this, our management is involved as well, and it has to be approved by our management, who is going to access the engineer that is assigned to this. And that grants the temporary access to customer database, or in this case, a database for investigation. So let me go specifically to look at SQL itself. And the first thing that to support the customer logbox, what we've done is we added additional auditing option that you can see on the right side that can be found under the SQL Server under auditing. And this option is called auditing of Microsoft applications, which is in preview. This is in this red box, and customer has enabled this auditing. The effect is that would monitor all Microsoft engineering execution or what was done to this particular resource, to this particular database. The access to the database is through JIT, just in time, With the fixed expiration time, typically it's 8 hours. This is how much the engineer has. And as I mentioned, it's access this specific resource, one database. Now the access is granted through the Azure Active Directory authentication for this particular engineer who is involved in it, and requires the MFA, the multi-factor authentication, the second factor authentication. And once this is provided, a temporary account is created in Azure SQL. So with this, let me show you the a demo, which is actually a recording that was done by Microsoft PMs, by Kai and Sandeep. And I'm going to focus on a specific part of it, which is related to SQL. So this recording it takes much more time, but I will only focus with my narration through the certain part of this, going through the end-to-end scenario. So let me open this recording, and what we have here is the following situation. So customer wants to gain space in the database, and it measures what's the current space that is occupied, and it finds out through the SP space use that typically that it takes around 6 gigabyte. Now, customer has a table that has 2 million rows, and checks that yes, these are 2 million rows, and decides to gain space to delete half of the rows. So it deletes every second row here, and after this, it checks how many rows do we have, and we have roughly 1 million. So with this, the expectation is that when customer measure the space, that he can gain this space for the deleted rows. But here, obviously, the answer is no. We have the same space as it was before, and this is the known SQL behavior that people involved, they know exactly what's going on. However, a customer doesn't know, so wants to open a ticket, a support ticket. But before doing it, a customer needs to go to the data, to the server, to his server, and open the new feature, the Microsoft DevOps auditing, which is here, which we rename to the auditing for Microsoft support operations. And as you can see, you can also click the log analytics there, where we will store the data. So with this in place, we can the customer can open a ticket, a support ticket, and this is a normal process that we do today through the portal, where we give the necessary data, the subscription. We talk about what resources are we having problems in. In this case, this is a SQL database. Then we need specifically to indicate what server and what database. And this is the database where we are trying to gain the space here, plus additional informations, a summary, what we try to do, and as well as what type of issue this is, as is classified in this case, like query performance and performance issues, log space issues. There are additional informations, still a regular process, where we add the timing, so the date and the time when it happens, that we can monitor the progress. And again, giving slightly more information here, exactly what was done and what was the expected outcome that didn't happen. With this, we can submit a ticket, a support ticket. So this ticket is supported, and we receive a confirmation on this. We get a regular support ticket, and on this we get an update from the CSS engineer, introducing himself, asking probably for more details, in this case to exactly articulate what was done and what was expected, what's the problem. With this, the engineer goes and analyzes this problem, However, if it's not possible to be really provided by the engineer, this analysis, the engineer involves the product team, and the product team comes with the answer saying, yes, there's a solution for this, run the following DDL statement, which is alter index. However, the customer doesn't want to do it. So customer wants us to help, to get help in this, and ask to send a ticket to the Lockbox that we can continue this process and allowing the engineer to access customers' data. The answer from support is, yes, we will send you the Lockbox ticket. So now customer goes to the Lockbox and review the ticket that was sent there. There are some specific data about what was done in the past that can be seen if the customer clicks on this particular request. There was all activities coming from the past, as well as a specific resource that is needed, that needs to be accessed by the engineering team. So this is the specific database. And there's a justification part where customer needs to type in, and that's pretty much for the company compliance officers from the customer side and also from our side, where there's an explicit request for assistance and then acceptance for this. So in the Lockbox, we accept it. From this on, engineering team can access the data, can go there and fix the problem, and come back and with the update saying, well, the problem was fixed. So whatever is needed, and then customer goes back to his original problem, checks the SP space, and finds that roughly we have a 5 gigabyte, the total space. So we gain 1 gigabyte of space. And that was the original goal, to get more space for this particular database. So with this, there is an update from the customer that is coming saying, yes, the problem was resolved. And the case is at this moment is resolved. However, there's the second part that is very important, and that means what was done on the engineering side. And this is where the auditing is coming in place. So we configure the auditing using the workspace that is indicated here. And now we go to Azure, where we see this that was during the execution by the Microsoft engineer. But the important thing is to look at the auditing records. And to do this, we have to select the filter in terms of the time that is of our interest. We check this, we get different entries there. Many of these entries are coming from this initial SSMS that was started, but there are two of them, which is viewing the index physical stats and executing later on the alter index. So these two operations were executed by Microsoft engineer. So these operations, first of all, they are documented, but also for each of them, we can create alerts. And these alerts can be sent later on to playbooks and redirect to special audience, to specific team that is representing the customer side. So with this, I like to conclude this demo. Let me go back to the original slides and let me summarize what we've seen here. So what we've seen here is the end-to-end scenario, beginning from reporting a CSS, we're reporting a support case to support engineers, and then going through the whole cycle that exists today, and also requesting the assistance from the product group, accessing the data. accessing a specific database through the Lockbox. Once this is done and once the case is resolved, customer can review through the auditing records what exactly was executed by the engineer, by the product group, and can create also the alerts for the documentation that will be sent it to other members of the company. So that concludes my presentation. There's a call to action for this, and we sign up for the customer lockbox that is in the public preview, as well as to listen to the full recording on the database protection and transparency in Azure. And with this, I would like to thank you for your attention, and I would like to hand it over to Rohit, who will talk about the network security improvements.
Hello folks, my name is Rohit Naik, and today I'm here to talk to you about some improvements that we've made in the network security space when it comes to securing your access to your databases. Historically, SQL database has always allowed you access via the public endpoint, and you may be familiar with using managing IP-based firewalls. With Private Link, we have moved to the spectrum of allowing you private connectivity to your SQL database. And the way to think about this is simply imagine you have a logical SQL server as it is today, and you have a client. Say, for example, here, let's assume you're running SSMS on an Azure VM inside of a virtual network. What Private Link does is creates a link or a connection from this virtual network to your SQL database, and it uses a private IP address from the virtual network's range. So that is the concept at a very high level. Benefits of this are that you get a private endpoint, which is a private IP address from which you can connect to your logical SQL server. From an application standpoint, your connection string remains unchanged. And since this private endpoint exists in the context of a virtual network, you can connect to it using ExpressRoute or VPN. Now, the private link pattern is being currently in GA for SQL database storage and many more services. Let's peel off the layers a bit and understand what exactly is a private endpoint and how it works. So for you as a customer, you'll see this private endpoint resource being created in the portal. But behind the scenes, it really is a combination of three different things. Number one is, what is the private link resource? As in, what is the PaaS service that you are trying to connect to? In our case, it is Azure SQL database, but there are many more. Number two is, what is the virtual network and subnet where you are creating this private endpoint? So you need to give that as an input to the process. And number three, a private DNS zone. So the DNS zone is what does the mapping of your logical server to the private endpoint. So that is what ensures that when you're trying to connect to your server within the context of the virtual network, that the traffic is routed to the private endpoint. In terms of how you can connect to the private endpoint, we support all scenarios that are supported by Azure networking. So here I have a private endpoint within a virtual network. I can definitely connect to it using a client in the same virtual network. For simplicity's sake, I'm using an Azure VM to represent a client, but could be anything else. Then you can connect using VNet peering, where your client is located in a peered VNet. From a networking standpoint, you can enable more complex scenarios by introducing a VNet gateway, which then allows you to have connections from on-premises, either by using VPN or ExpressRoute. and also VNet to VNet connections that can go across regions. So overall, that is the value prop of private link, and we are also introducing private link for managed instance, which is in the pipeline. Now we've talked about private link and understood that it allows private connectivity to SQL database, but then you also need a way to shut down public connectivity if you so desire. So it's exactly for this purpose that we've introduced a knob in the portal called Deny Public Network Access. And we also heard the feedback from customers requesting enforcement of a TLS version, since many customers want to enforce TLS 1.2 at the server level. So this too is available in the portal right now. I'll do a brief flowchart here to make you understand how deny public network access works. So by default, this setting is set to no, which means public access is allowed as it is today. And when a connection comes in, we evaluate whether it matches anything in the VNet firewall rules. If not, we will check if it matches anything within the database level firewall rules, which are stored in sys.database firewall rules DMV. If so, then you get access to the specific database. If not, we check within the server level firewall rules, which is stored in sys.firewall rules. And this also checks for allow Azure services, which is a special type of firewall rule with a start and end IP address of 0.0.0.0. So this, what I'm showing you till now, is how your connection gets evaluated when you are coming in through the public endpoint. Now, once you set up a private endpoint and flip the deny public network access to yes, what happens is you can only connect via the private endpoint, and all these methods of connecting via public endpoint are not allowed. So these are the high level features that we have introduced. And now let me take you through a demo to make sure that you understand these in more detail. So for purposes of the demo, let's start by looking at the Azure portal. So here I have set up a scenario where in the West US region I have this PL demo SQL, which is my logical server, and I have a client VM in East US. And I want to make sure that these two can talk to each other using private link. And here you'll see I have already created a private endpoint in the same virtual network as the client VM. So then this virtual private endpoint allows you to connect to PL demo SQL over private connectivity. So let me go into the VM and show you a few things. So the simplest way to check how my connectivity is resolving is by doing an NS lookup. And when I do that, you see that for my database, it resolves to this 10904 address, which is the address of the private endpoint. I can also check and make sure that if I run a utility called psping, where it actually connects to the port 1433 and that IP address when I try to connect to my database. And then I can also now just confirm this is the IP address of the VM. And if I connect using SQL CMD, that again. Then let me run this command. So you see that my IP address is 10914, which is the IP address for this VM, right? Let me just show you what happens when I try to connect from, say, my laptop, which for which I have enabled public endpoint connectivity. So I run the same command. And here you see that my connection is coming in through this IP address of 73.53.40.9, which I have actually allowed in the firewall on the SQL database. Okay. So now let me show you how we can block this access and only connect. So at this point, my default is set to no, which means I can come in via any of these firewall rules as well as from the private endpoint. Now let me show you how you can flip this to be only private endpoint connectivity. So I click yes, I click save, and that's about all you need to do. So okay, let's make sure I run the same command again. And now you get an explicit error saying connection was denied since deny public network access is set to yes. To connect to the server, use private endpoint from within your virtual network. So this is basically telling you that this server is set for private only connectivity. And then everything that you have defined here, you can see that this is all grayed out. So you can no longer change any of these settings related to the public endpoint. And now let me bring it home with another demo to make sure how the minimal TLS version works. So for example, here I have actually set the minimal TLS version to 1.2 for the server. I'll go back to the virtual machine. And I have this client tool called dbeaver, and the reason I like to use it is because it has the ability to edit the connection for the JDBC driver. So in the JDBC driver here, I can set up TLS version. Currently is set to TLS 1.2. So if I go and try to connect, you'll see that it is able to connect to the database here. It should load shortly. Okay, so I'm able to load the database and connect to it. Now if I edit the connection, and currently the server is only going to allow TLS 1.2 or greater, and I say I want to connect using TLS version 1, and say yes. And now when I try to connect, I will get an explicit error message. So I get a error message saying login failed with invalid TLS version, which essentially is saying that I'm trying to connect with a TLS version that is lower than what the server is configured for. So with that, I conclude my demo for the various features that we've introduced. And then in the PowerPoint deck, you'll find a list of resources and videos where you can explore these demos in more detail.
Hi, my name is Jakub Szymaszek, and I'm excited to give you an update about latest innovations in the data protection space in Azure SQL Database and Managed Instance. Many of you and many customers are concerned about the confidentiality of your sensitive data and protecting the data from high-privileged but unauthorized users. In Azure SQL Database Managed Instance, we've been addressing this problem for the last 5 years with a technology called Always Encrypted and its confidential computing capabilities. So Always Encrypted is a client-side encryption solution that ensures that your data and the keys protecting the data are never exposed in plain text inside the database system. So that provides great security, but offers quite limited computational capabilities, namely Always Encrypted today supports just one operation, equality comparison on encrypted database columns. So now we will be substantially expanding the set of these confidential computing capabilities by leveraging the technology called secure enclaves. So a secure enclave, think of it as a trusted execution environment that is embedded inside the database engine. It's a black box to the rest of the database engine, including the operating system on the machine hosting it. So no one can see what's inside the enclave. And now we can leverage these strong security properties to support more computations on sensitive data. The data can be now safely decrypted inside the enclave so that we can support rich confidential queries, including pattern matching, comparison, sorting, joins, indexing, and more. We can support in-place encryption so that you do not have to move your data outside of the database for cryptographic operations such as initial data encryption. So this feature has been available in SQL Server since 2019. Now you can expect it to be available in preview soon in Azure SQL Database. And I want to share a little bit more about how this feature in Azure SQL Database will differ from its counterpart in SQL Server 2019. So from the functional point of view, it will offer the same capabilities, plus in fact a few more, like will support sorting with order by on encrypted columns. But most importantly, it will be much easier to use, which is what you would expect from a platform as a service environment Azure SQL database is. So in Azure SQL database, we'll be using Intel SGX hardware enclaves, which are available in a subset of Azure hardware fleet. So you will have to ensure that your database uses a specific hardware configuration, which will ensure that the database is placed on an SGX-enabled hardware. And once you do that, the enclave will be configured and initialized for you automatically. You will not have to do anything for that. The other thing we'll be simplifying is the attestation workflow. So if you are familiar with the feature in SQL Server 2019, you know that before the client can authorize the use of the enclave for sensitive data processing, it needs to verify the enclave is trustworthy. And for that, we have implemented the attestation process, the enclave attestation process. And in Azure SQL Database for that, you will be using a new service called Microsoft Azure Attestation, which provides an easy-to-use platform as a service solution for attesting enclaves or trusted execution environments. So as I mentioned, the public preview of this feature in Azure SQL Database is coming soon. But we'd ask you not to wait until then. You can share your thoughts, your feedback with us on this feature and exciting technology now. I also want to mention there is an ongoing limited preview. If you're interested in joining it, please let us know as well. I also want to mention that Always Encrypted with Secure Enclaves is a key component in a broader initiative, broader effort at Microsoft called Azure Confidential Computing, which brings confidential computing capabilities to other Azure services as well. So if you're interested to learn more about it, here's the link you can use to find out more information. So we talked about data confidentiality. How about data integrity protection? So the same concerns, the same questions, or similar questions and concerns apply to data integrity. How do I protect the integrity of my data from high-privileged users or from hackers, malware? How do I know my data hasn't been tampered with? So businesses, organizations have been solving these problems so far with two quite expensive and inefficient methods. One of them is manual audit, and the other is engaging external intermediaries, trusted intermediaries. And both these methods are slow, costly, and quite unreliable and error-prone, which is why organizations are looking with a lot of hope and enthusiasm at ledger technologies such as blockchains, which basically provide an automated solution for protecting data integrity. However, blockchains, being distributed systems, come with lots of complexities. And quite frankly, they are an overkill for centralized applications, such as system of record applications that very often need data integrity protection. So we started looking into this problem, and we asked ourselves a question: what if a customer doesn't need the decentralized solutions such as a blockchain? Could we perhaps incorporate these blockchain capabilities, the benefits of blockchain, into the database system, basically to bake trust into a relational database, to make the data that you store in a database tamper evident. So we started an incubation effort that basically expands the capabilities of an existing technology called Temporal, which captures historical changes, history of transactions, changes, queries against data stored in a given table. But now we are expanding Temporal and these capabilities so that database system generates cryptographic proofs or digital receipts that you can later use to cryptographically, mathematically, and most importantly, instantly verify the data in your database hasn't been tampered with. So this technology would be available across the SQL product portfolio. It would be baked in the database system, as I said. And what this means to you is that you don't have to deal with the complexity of an external solution, such as a blockchain. You can leverage the same reporting BI development tools you are familiar with, and you can benefit from the proven reliability, security, and performance of an enterprise-grade database system, SQL Server, and related and the products that leverage it, like Azure SQL Database and Azure SQL Managed Instance are. So if you are as excited about this technology as we are, we'd like to share your feedback, share your thoughts, let us know what you think. And again, I want to let you know that there will be limited preview opportunities coming up soon. If you're interested in joining that, that's another reason to complete this survey as well. So last but not least, I want to give you a few updates about the enhancements we've made in transparent database encryption. All these enhancements listed on this slide are in public preview now. One of them is support for managed HSMs, which is a new FIPS Level 3 compliant offering from Azure Key Vault. Now you can store the TD protector in a managed HSM when you use TD with customer managed keys. You can also use TD with customer managed keys now in Hyperscape. And we now also support what I think can be called or referred to as double encryption or 2 layers of encryption at rest. We recognize the fact that many customers, especially in the government and finance sectors, need more than 1 layer of encryption at rest. So now, with this enhancement, you can encrypt your data using transparent database encryption with customer managed keys as the first layer of protection, and you can also leverage new infrastructural encryption at rest at the infrastructure layer. So this feature is available in public preview now, but you cannot enable it by yourself. So if you're interested in trying it out, please let us know. Here's the email address. Send us an email, and we will let you know how you can get access to this new technology. So with that, let me summarize what we have covered in this session. You've learned about Azure Defender for SQL Anywhere that protects your data against common threats like SQL injection across your entire data estate, including on-premises databases and databases in the cloud. You learned about Customer Lockbox, which allows you to control actions performed by Microsoft operators when troubleshooting customer incidents, when responding to support cases that you file. You learned about Private Link that enables private access to your database in an Azure SQL database. And we also talked about the latest innovation in the data, in the confidentiality and the integrity protection space. We talked about always encrypted with secure enclaves coming up in SQLDB and new built-in ledger capabilities in the incubation state. So with that, one more time, I'd like to encourage you to share your feedback and input with us and sign up to any previews, early previews you might be interested in. And with that, I'd like to thank you for watching and your interest in Azure SQL security features. Thanks.